back side of this kinetic potential energy practice. Okay? Each one of these sections, let's go ahead and take an approach at this. All right, I'm going to briefly show you each section, and then I want you to attempt them on your own. Okay? So here it's asking F or FW. What does F stand for? Well, that's force. FW, that's weight. What are both force and weight? What are the units of measure? Newtons. So 8 newtons. V stands for velocity, units of measure. Lowercase p, haven't taught that one to you yet. Momentum. Momentum, units for momentum are kilograms, meters per second. Right there. Okay, so you can eliminate that one. All right, the others you do know, H, height, work, and energy, and then uppercase P is power. Next section, potential or kinetic energy, or both. Okay, so a car traveling 45 miles per hour, a rock on a ledge 5 meters high. Ledge, there's that word again. All right, a ledge is an edge from which you can fall from. Okay, so that's what that word means. A car is resting at the top of a hill, a ball thrown into the air and still moving, a ball rolling on the ground. Well, I'm going to give you a hint here. Right here, this one, a ball is thrown into the air. That tells me it's got height. And it's still moving, so it's got velocity. So if it's got both height and velocity, it has both kinetic and potential energy. All right. Circle the one with more kinetic energy. Well, we have a 25 kilogram mass, and we have a 30 kilogram mass, and they're both going 5 meters per second. Well, our formula for kinetic energy is 1/2 mass velocity squared. So both the mass and the velocity will affect the kinetic energy. So we've got two objects, one 25 mass, one 30 mass. Which one is going to have more kinetic energy if they're going the same velocity? It's going to be the one with more mass. Okay, so repeat that here with those other problems. Over here we've got a matching definition section. And here circle the one with more potential energy. Okay, so potential energy is mass times gravity times height. So you have to consider all those factors. The gravity shouldn't change unless you go to another planet. But mass and height. So we have a 25 kilogram mass or a 30 kilogram mass, but they're both at the top of a hill. Okay, if they're both at the top of a hill, they have the same height. But 25 mass and 30 kilogram mass, they have different masses. The one with the greater mass is going to have greater potential energy. Okay, continue the same process with that. The rest of these are problem-solving process. So identify your variables, identify the question, and work through those answers. Okay, I'm not going to do any demos on that one. At this point, I want you to pause and work through the answers. As you work out these problems for problem-solving process, go ahead and use 10 for gravity just to make math easier. Starting at the very, very top here, are matching our variables with their units of measure. Velocity is meters per second. Height is in meters. Work and energy are both measured in joules, and power is measured in watts. Okay? Potential and kinetic energy is the potential and kinetic energy, or both. So a car traveling 45 miles per hour, that's a velocity. So it's moving, so it has kinetic energy. A rock on a ledge, all right, is just sitting there. It's got height. If it's got height, it's got potential energy. A car at rest at the top of a hill, so it's not moving, but it is the top of a hill. It's got height there, so we have potential energy. All right, we already did the one that's both. And then a ball rolling on the ground. On the ground tells me there's no height, but it is rolling, so it has velocity, so that's kinetic energy. Circle the one with more kinetic energy. So, two masses of two 10 kilogram masses. Okay, one's going 75 meters per second, and the other one's going 45 meters per second. Well, they have the same mass. The difference are the velocities. So the one with the greater velocity is going to have the greater kinetic energy, the one going 75 meters per second. A car at rest or a car rolling down a hill. Okay, it's just asking about the kinetic energy. So the rolling is the important thing. If it's moving, it has kinetic energy. That one doesn't have any kinetic energy because it's not moving. A heavy bike or a light bike? All right, well, we're going to assume they're both moving. Both moving. The same speed. That should have been clarified in there. But which one's going to have more kinetic energy? Well, the one with greater mass. And the one with greater mass is the one that's heavier. So the heavy bike. Top section over here with matching. Okay. Kinetic energy, all right, is the energy of motion. Potential energy, all right, is the energy of position. Okay. Units for energy and work, that's joules. How far above the ground an object is, that's height. And work uses energy, can create energy calculated by multiplying the force times the distance. That's work. Okay? Circle the one with more potential energy. So the car at the top of the hill or at the bottom of the hill. Which one's going to have more potential energy? The one with more height, in this case, because it's the same car. So top of the hill is going to have more potential energy. A plane on the ground or a plane in the air. Okay? The difference, it's the same plane. So the difference is going to be whether it's on the ground or in the air. That's just a question of height again. So the one in the air is going to have more height, it's going to have more potential energy. A full plane loaded up with merchandise or people and luggage, I don't care what it is, but it's full. Or an empty plane, there's nobody in it, there's nothing inside. Both of them are flying, okay, so there's a pilot inside. But both of them are flying, so they both have height, they have the same height, but the fact that this has more mass, it's going to have more potential energy. Okay, problem-solving process. Let's do the start ones on the left side. Okay. We have 5 kilogram object, 3 meter ledge. All right, again, that word ledge. All right, it's just an edge from which you can fall from. So that 3 meters is measuring this part right here, how high that ledge is, so that's a 3 meter height. Kilograms measures mass. Question is asking for potential energy. Potential energy equals the mass times gravity times height. So, for the sake of simplicity, let's go ahead and use 10 for gravity. If you didn't use 10, just know it's going to be a slightly smaller number that you got on your calculator. So potential energy, 5 for the mass times gravity of 10 times height of 3. 5 times 10 is 50 times 3 is 150. 150, because I'm solving for energy, joules are my units. Next one, we've got a 20 meter tall hill, so that's height. 10 kilograms measures mass. Question is asking for the potential energy. Potential energy is mass times gravity times height. So mass of 10 multiplied by gravity of 10 multiplied by height of 20. 10 times 10 is 100 times 20 is going to be 2,000. Units measure joules. Okay. Now we have a 25 Newton object, 3 meters up. 25 newtons, newtons measures force, 3 meters up, that's going to be its height. How much potential energy does it have? All right, well, potential energy is mass times gravity times height. This question probably stumped you, but it's okay. Let me explain. We have a force given to us, 25 Newton object, okay? What's that describing is the force of weight. Force of weight is mass times gravity. Mass times gravity is in the potential energy formula. So I'm going to rewrite the potential energy formula, replacing mass times gravity with FW. potential energy equals force of weight times the height, because that force of weight represents mass times gravity. So if I have the force of weight and I have the height, all I have to do is multiply them. So my potential energy would be my force of weight of 25 newtons multiplied by a height of 3 gives me 75 joules. Okay? We have a 3 kilogram object, 300 joules of energy. Kilograms measures mass. The question is asking for height. All right, if it's a question of height, what kind of energy must it be? Well, it's potential energy. 3 kilograms of mass, 300 joules potential energy. Height is the question. So if height's my question, I need the potential energy formula rearranged to solve for height, which is in your notes. Height is equal to the potential energy divided by mass times gravity. Parentheses around the mass and gravity. So when you put this in the calculator, make sure you include those parentheses. In your calculator is going to be 300 divided by parentheses mass of 3 times gravity of 10 close parentheses. So 3 times 10 is 30. 300 divided by 30 is 10. Height measured in meters. Okay, next problem, moving up to the top of the right side. 4 kilogram rock, 10 meters per second. Mass and velocity. Question is asking kinetic energy. Kinetic energy is 1/2 mass velocity squared. So I'm going to put in the calculator 0.5 multiplied by 4 multiplied by 10 squared. 10 squared is 100. 100 times 4 is 400. Half of 400 is 200. 200 joules. Energy measured in joules. 8 kilogram cat. Kilogram measures mass. 4 meters per second. That measures velocity. Question is asking for kinetic energy. Kinetic energy is 1/2 mass velocity squared. Plug in the values. Ke equals 0.5 times 8 times 4 squared. 4 squared is 16. 16 times 8, then 1/2 of that. $64 is your answer. Kinetic energy measured in joules. We have 18 joules of energy. 3 meters per second is velocity. Question is asking for mass. If it's got velocity, this is our kinetic energy. So we need the kinetic energy formula rearranged to solve for mass. That's in your notes. Mass is equal to the Mass is equal to 2 times the kinetic energy divided by the velocity squared. Go ahead and plug those values in your calculator. 2 times 18 divided by 3 squared. It's going to look like in your calculator. Calculator says 4 units measure kilograms for mass. 4 kilogram bird, that's measuring mass. 8 joules of energy. And the question is asking about how fast, which is velocity. So we have kinetic energy. Kinetic energy formula rearranged to solve for velocity is the square root of 2 times the kinetic energy divided by the mass. When you put that in your calculator, it's going to be that little symbol right there. Square root symbol shows the parentheses. Show you how that works. The second button, and then all the way down here, the square root there in yellow, like that. So we get the square root, and then type in the 2, and then multiplied by your kinetic energy of 8, and then divided by the mass of 4, and then you'll close the parentheses. So 2 times 8 divided by 4 gives us 2. So 2 meters per second, because its velocity, is your answer. Okay, last one. We've got 25 Newton, that's force, 6 meters, that's distance. Question is asking for work. Well, if you notice, that's not either the kinetic energy formula or the potential energy formula. That's the work formula. Work is force times distance. So we got to take the 25, multiply it by 6, and that gives us 150 joules of work. Remember, energy and work are both measured in joules. And that is the worksheet.